Yes, student, listen. Today we go for the ring opening reaction and ring making reaction. Ring opening reaction, wherever the ring strain is there. You know the ring strain more, for example, cyclopropane. Okay, cyclopropane. So there is a ring strain too much. So you know the 6-member ring is there. There is no strain in the 6-member ring. Okay, there is no strain in the 6-member ring. So compare with the cyclopropane. This is cyclopropane. Okay, cyclopropane. The angle is 120. Okay, the angle is 120. So ring strain more. So therefore it comes to the linear chain. If any nucleophile approach, it comes to the linear chain. Okay, that is a ring opening reaction. Okay, ring opening reaction. Maybe the very simple I can give for cyclopropane, CH2, CH2, CH2. Otherwise, cyclopropane. So here, see, listen. Here what happened? The bromination, suppose Br2, okay, Br2 in presence of carbon tetrachloride and dark condition. So what happened? Here CH2, Br, CH2, CH2, Br. So the ring will open, then the bromine addition is there in the 1,3 carbon. So 1,3 dibromopropane. Immediately the ring open to release the ring strain. Okay. And next, if the addition of hydrogen iodide, Hi, what happened? CH3, one side hydrogen, another side, another end iodide. CH2, CH2I, one iodo-propane. One iodo-propane. Okay, one iodo-propane. Similarly, the sulfonation, suppose H2SO4. H2SO4 means H plus HSO4 minus. H one side, HSO4 another end. Okay, HSO4 another end. That's why we get the CH3, CH2, CH2, O, SO3H. Okay, OSO3H. Then if you add only the hydrogen with the nickel, that is a Ronnie nickel. Nickel is the surface of that hydrogen absorbed on the nickel surfaces. Then you get the hydrolysis. Then you get the CH3, CH2 and CH3. N-propane. You get the N-propane. So everything based on the cyclopropane. If you take the cyclopropane, add the reagent is H2 nickel, that is a isonating agent. You get the N-propane. Okay, N-propane. That is a ring opening reaction. In case of sometime they given the some other reactant also. Okay, there is a huge ring strain. Wherever the ring strain is more, in that case the ring opening reaction is there. Okay. So simple only. You take a cyclopropane, Hi means you get a N-iodopropane, Cl2 or Br2 in the dark condition means you get the 1,3 dichloro or dibromopropane.
Sir, what did you write at the top? P.
Ring opening reaction.
Yeah, no. That first reaction, the first one.
Br2, CCl4, carbon tetrachloride at dark condition. CCl4 as a solvent. Carbon tetrachloride. Okay, carbon tetrachloride as a solvent at the dark condition. Maybe here Br2 or Cl2. Cl2 means 1 and 3 position, Cl is there. Br means 1 and 3rd position, Br is there. Okay, and next we go for some other reactions. That is, I'll take it in the Google itself. What happened? The epoxide. Epoxide is break and it form a corresponding alcoholic functional group substituted linear compound. That is a also ring opening reaction, epoxide reaction. Okay. May move the next one. In case of this is CH3 epoxide ring. Here you can add RMGX. RMGX is a BR, Grignard reagent, right? RMGX, that is a Grignard reagent, and in presence of acidic medium, H plus. In presence of acidic medium, here the ring opening reaction happened. So there you get the 1, 2, 3, 4, 5. Yeah. 4, 5. Here OH, here CH3, here CH3. That is a ring opening reaction. See how many number of carbon is there? 1, 2, 3, right? 3 carbon. And here RMGX. This is a ethyl magnesium bromide. Ethyl magnesium bromide. So here 4, 5. So 1, 2, 3, 4, 5. 4, 5. Okay, 4, 5. There, the R and MgX group approach here, the third carbon. The third carbon, MgX approach the third carbon, then the ring opening here and it go to the negative side, therefore O minus. When you add the proton, that it comes for the OH. OH, that is a ring opening reaction because that is a huge strain, ring strain. And so automatically the ring opening reaction is there. Okay, you understood what I am saying? Just here the ring opened, the MgX it approach here, the third carbon side, then this bond is shifted towards the O minus, so you get the O minus, and next step when you add H plus, you get the OH as the functional group. Okay, OH as the functional group. Suppose the same, we have the same NaOCH3, NaOCH3 in presence of acidic medium. This is the first step, this is the second step. Protonation is the second step. Okay, or else hydrolysis, hydronium ion addition. So what is your product? What is your product? Just you write it. What is your product? Na plus OCH3 minus. Therefore, that OCH3 minus here and here OH. Therefore, what happened? OCH3. That's it. OH CH3. This is your product. Very simple. Okay. OCH3, Na plus OCH3 minus. That O minus is approached towards this carbon, third carbon. Then the bond shift is there. That is in form of O minus. So if you hydrolysis, you get the alcoholic functional group. Anything else? Okay, here RMGX also OCH3 minus, NaOCH3. Okay, right. And next, so everywhere they can given different way, but the concept is same. The wedge base side towards upward side, epoxide group is there. Here CH3 is there. When you add the reagent, what reagent you can add? Base, NaOH. NaOH, second step, protonation. What is your product? What is your product? What is your product? So any of this also comes under ring opening reaction. So here what happened? The OH minus. Okay. Na plus OH minus. Okay. So what you get the product here? So here the dash pay CH3 is there. Okay. CH3 is there. What happened? Here dash pay CH3 is there means the wedge pay alcoholic group. Alcoholic group. Here the wedge pay is the alcoholic group means here the dash OH. That's it. That is, you know, the syndiol. Syndiol product, antidiol product, front and back. If one of the alcohol is the front side means other alcohol is the back side. That is diol. Okay, diol. That's why how you identify here the dash side is a methyl group is there. So definitely again the same side is not a OH group. Definitely towards the front side or else in front of the board. So in front of the board one OH is there means next carbon back side of the board. That's it. Okay. Syndiol, that is an antidiol. Syndiol means same side. Antidiol means back side. Front and back. Okay, front and back. Huh? Yeah, this is a final product. This reagent CH3 LH, lithium aluminum hydride. Lithium aluminum hydride, that is a reducing reagent LH. Then you do the protonation CH plus. Here the first step, what you get the product. So almost we break the ring, you get the alcoholic product OH. That's it. CH3 CH3. Because this is a hydrogen source. H plus Li Al H3 minus. That Li Al H3 minus approach this side. Again it bond shifting is there. Therefore O minus. That H plus protonation it's happened here. Therefore you get the alcohol. Again that lithium aluminum hydride it remove from the bond when you hydrolysis. Okay. That we can do it in the last end of the third unit, that is reducing agent, lithium aluminum hydride, sodium borohydride, Rane nickel, sodium ammonia, that is bridge reduction, everything. We move. Yeah, the next one. Suppose go complicated. Five-member ring. Okay, you take the five-member ring here. Hydrogen. What is the meaning of this reagent? I can write it here very simply. C triple bond C hydrogen CH. That is the meaning. We do not do it. Five-member ring C triple bond CH. C triple bond CH. Okay. There you can add sodium. What is the reagent we can use it? NaNH2. Then you take a epoxide. This is the first step. Then, as usual, the protonation H plus. So 3 steps protonation. So what happened? The first one NaNH2. NaNH2 it remove the proton from that alkene. Then here minus star. That minus star approach the here and ring opening reaction is happened here only. You understood? This is a base. It removes the proton from here. Therefore, negative charge. That negative charge approach towards this carbon and ring bond shifting is there. That is a ring opening reaction. Therefore, what happened at final product? Okay. Okay. Alright. Here itself OH. Because the tertiary carbon only form a carbanion, carbocation is more safe. Therefore, this is a tertiary carbon. Here only these group come and approach.
Sir, is there another carbon there after that?
Here approach is O minus. Therefore, O minus means when you protonate, it protonate this side. Therefore, tertiary carbon only OH minus.
Sir, there is another carbon
Where?
there. See, this one.
No. 1, 2, 3, 4, 5, 6. Right? 1, 2, 3, 4, 5, 6.
Yeah, that's it.
That's it. You got it? Maybe color we can use it. See, this is a proton removed from the base. Therefore, this carbon come and approach. Then O minus. Then O minus. When you do the protonation, you get the alcohol. That's it. You get the alcohol. Okay. Here also next one is if you take a 5-member ring, you count the number of carbon, that is main, because the number of carbon, based on the number of carbon only CH3. If you do here sodium cyanide, NaCN, sodium cyanide, then hydrolysis. Simply you can take Cn minus, Second step is the H3O plus, that is hydrolysis, workout process. So when you work out that one, you get the diol, the same diol. So here CH3, here OH, here also OH. That's it. That one we discussed the first step itself. The first step itself, here they given the CH3 is the back side of the board. That's why we get the diol is the front and back. Here they didn't mention anywhere. On the plane only CH3 is there. Therefore your alcohol also plain. That is a ring opening reaction. Okay, ring opening reaction. Now we go for the ring making reaction. Okay. Next is a ring making reaction. That is a Dickman condensation. So when we Dickman condensation, we move the ring. What is the time? Time there? Time, 250, 310, up to 20. Okay. Okay, Dickman condensation. Normally the Dickman condensation is happened in the diester, dicarboxylic ester. Okay, dicarboxylic ester. The ester group is there in the two sides of the alkane group. Okay, so that is a diester. So wherever the diester is there, the ring making reaction is possible. Okay, so for that, normally we prepare the cycloalkane based on the Dickman condensation. For that we need the beta keto ester. We take a beta keto ester, dicarboxylic acid. CH2, CH2. Yeah, if you had C2H5O and A there, it remove the proton from the beta carbon. Okay. Yeah, listen. So what is the first step? The removal of the proton from here. The removal of proton. So you get the negative charge. Right? That is the first step. So here you look at it, CH2, CH2, then CH minus, then C double bond O, O C2H5. Similarly here, CH2, C double bond O, O C2H5. You got it? How the carbon ion formation? Students silent. Carbon ion formation. The proton is removed from your base. So you get the negative charge. Then the negative charge, it approaches opposite side or else another end of the ester side. So then this migration is there. Okay. bond shifting is there. Now you count 1, 2, 3, 4, 5, right? Therefore 5-member ring. 5-member ring formation. How the ring is there? How many number of carbon you count? Then you do the ring structure. So 5-member ring, right? So 5-member ring. Then the 5th ring, what happened? O minus OC2H5. OC2H5. Am I right? 5th carbon. In the first carbon, this is the first carbon, right? First carbon, C double bond O, OC2H5. OC2H5. Right? Just ring making. That's it. Now what happened? Here O minus is there. Therefore, that O minus shift to make a keto group, and this one it remove. Therefore, what you get it? So you do the 5-member ring first. Here C double bond O, C double bond O, OC2H5. OC2H5. Is there any doubt? Any doubt? Suppose if you do the hydrolysis, okay, then when you heat the solution, what happened when you do the hydrolysis? This ester group, it comes to the carboxylic acid. Then when you boil the solution, the CO2 it remove. Therefore, finally you get the keto group. That is cyclic ketone. Cyclic ketone. If you further reduce, you know the keto group reduction. If you add any hydrogen sources, you get the, that's it, cyclopentane. Cyclopentane. You stop the reaction up to this, or else if you stop the reaction up to this, no problem. This is a Dickman condensation. Dickman condensation. Normally, this one up to, you know this is how the keto group it formed. Any doubt? First, removal of the proton, that is the first step. When you add the base, removal of the proton, that is the first step. Where it remove the proton? From the alpha carbon. Alpha carbon. I know, I explained last class itself what is the beta carbon, what is the alpha carbon. Where the functional group or else notified group attached carbon is the alpha carbon, neighboring carbon is the beta carbon. So therefore this is the alpha carbon because that is a ester group is there. So therefore the proton removed from the alpha carbon, you get the carbanion. Then the carbanion migration will be there, or else it make a ring. Where it make a ring? Because it won't move this side. Instead of that, this side only it may move because here it form a ring. Here it form a ring. Okay, therefore you count the number of carbon from the carbanion to where the carboxylic acid keto group present. So how many number of carbon? 1, 2, 3, 4, 5. That many number you can put it. Then O minus OC2H5. The first carbon have C double bond O, OC2H5. OC2H5 is there. So then the negative charge migration, and that is a hydrolysis step. So it move towards this side. Again the bond break will be there. That is a keto group. I am not changing anything. As usual, the rest of the group is there. Up to this you can stop. Otherwise, next also we can do it. That is hydrolysis and heat the solution. You get the keto group. Again, if you add any reducing agent, you get the cyclopentane. Okay. Any doubts? No. So here, where the bond breaking is there, where the bond breaking is there. we move the next one. So definitely one question will be there. Sorry, this CT3. Sorry, model exam or a separate test question.
Sir, there will be a CD3.
That is separate test.
Separate test, is it?
After CT2 question.
After so the entire portion, the surprise test you have any, what would be the portion?
That's what unit 4 and 5. Any doubt? Okay. What is your product? What is your product? So in the ring, 7 carbon is there, 6 number ring is your product. That is a clue. Okay. So how many number of carbon? 1, 2, 3, 4, 5, 6, 7. 7. Therefore 6 number ring is your product. Here OCH3, there OCH3. You ignore. Therefore, what is your product? 6 member ring is your product. You close your eyes. Just a 6 member ring. 1 carbon is a keto group. Another carbon is OCH3. That's it. That is your product. If 7 carbon is there, 6 member ring is your product. If 6 carbon is there, 5 member ring is your product. The 7th carbon is a keto group. First carbon is a same ester group. That's it. Very easy idea. Clue. What is your product? How many number of carbon is there? You count, except that OCH3 group or else OCPH5, whatever it is. So 7 carbon means 6 member ring is your product. 6 carbon means 5 member ring is your product. Okay. Maybe next you can do it. For our convenience, we can write it like this, but normally it's there in the long chain. Okay, normally the reactant is there in the long chain. So accordingly, you image the reagent. Okay, so what happened here? The first step, removal of proton. The removal of proton, as usual. The removal of proton, because when you add the base, the proton removed from the alpha carbon, that is also alpha carbon, the proton removed. Then the bond migration is there. Then you get the O minus. You got it? Everything perfect, right? So what happened? The first step, you do the O minus, OR, double bond, as usual here, OR, double bond, keto group. Any doubt? First step, no confusion. That's removal of proton. The second step, what happened? This pi bond is there. That pi bond is approached where the opposite keto group, then O minus. O minus. For your understand, maybe I can write it. This is the first step. This is the second step. Similarly here, this is the first step. This is the second step. This is the third step. Stepwise. Okay. What happened? Now the ring formation is there. Now the ring making is there. So what happened here? We get a 5-member ring. 5-member ring. Then O minus, because this O minus. O minus. Then OR. Neighboring group is the OR double bond O. This one is first, then second, third. That minus star migration, bond migration is there. Then what happened the next step? Next step, so this is a O minus, then removal of OR. So what happened here? OR, double bond O, double bond O, right? Double bond O. Any doubt? Nothing, right? So here, you look at here, 1 carbon, 2 carbon, 3 carbon. So therefore, this is a tertiary carbon. Tertiary carbocation is a very stable one. Therefore, here the proton is there. It removes the proton. Therefore, here the negative charge, that negative charge migrates towards this side, and here O minus. O minus. You got it? Already the base is there everywhere. That base is remove the proton from your wherever the proton is tertiary carbon, and carboxylic acid, alpha carbon, there the removal of proton will be there. So next step, O minus, double bond O, OR. So again what happened? That is the final product. Here alkenes. That is your final product. Okay, final product. So this is also Dickman condensation, ring making reaction. So this is a 5-member ring. Just now we discussed this is a 6-member ring. The same reaction only here. Same reaction only I do it here. Okay, and the previous one is a ring opening reaction. Ring opening reaction I can do it in the epoxide ring and cyclopropane. That's it. Okay. Any doubt? Please try to practice. So next class maximum no, one more class is there, right, before the exam? Thursday. So here after direct exam. That is lab is there. On Wednesday we have a day order 1, no class. Thursday exam. So this is the last class.